First off, thank you all for coming out here very much. Appreciate it. Do a quick introduction first, give you a little bit of background about myself. My name is Daniel Greenberg. I am a professor of game design at George Mason University in Fairfax, Virginia. Our program is a Bachelor's of Arts and Master of Arts program that allows students to learn to develop games. For those who are more programming inclined, the Volzhino School of Engineering also has a program that is an applied computer science degree in game design for students who are pursuing more of a programmatic route to game development. In addition to that, I also run Winterion Game Studios based out of the historic video gaming district of Clifton, Virginia. We produce Ion Gaming on YouTube, which is a show that does Let's Plays, reviews, and critical analysis of games. It's also where you'll find all our lecture panels that we've done in this year and previous years. So if you can't remember something I say here today, don't worry, it should be up on the website in a few weeks. So we're going to go over two topics first. The first one is going to be me mostly talking. The second one is going to be more of a demonstration. The first topic is going to be a brief overview of how games are made, or at least understanding sort of the core that makes a piece of software that is designed to be sort of this interactive piece of entertainment work. And then the second part is going to be hitting the ground running. I want everybody in this room to have a very basic idea by the time we're done here, how they can just go home, download some software that is completely free, run it on their computer, start poking away at a couple pixels, drag and drop a couple of functions or behaviors onto their characters, make a real simple music loop, a real simple character sprite, and have their first game. Everybody here should be totally capable of making games. That's why this is a beginner's guide to basic game development. And when that's done, if we have any time remaining, we'll do questions and answers here in the room. If we hit our time window, we can do questions and answer out in the hallway. So first, games are generally an iterative process. What I mean by this is when we're making games, we don't typically come up with, here's everything we want to do for the game, done. Once we've done all our planning, then we sit there and we code every single bit of our game, and then we're done coding, and then we step down and we test every single part of the game. That's more of what they call a waterfall model, which is actually an incidental method of software development that was accidentally developed by a guy in Texas Instruments in the 1970s who lived in my hometown of Clifton for a few years. As it was, bless you. As it was, the idea is that software should be made a little bit, tried, tested, see what works, see what doesn't, try a little more, work a little more, and test. So understand when we're going to be developing and when you're developing, it's an iterative process. You're going to be going over this again and again and again and testing your stuff and working on things to see what works and what doesn't. Understand that games are interactive programs. All you are doing is developing a piece of software that is designed to have responses read by the user. Like the simpler you can kind of drill this down, the better. We have this thing that we kind of call the main loop or the game loop. So you won't have to worry about this at this point in your software development pursuits because you're not designing your own engine, you're not programming your own engine in any language. We're going to be using a pre-built engine. But understand that we kind of have in a program this simple loop. And all we are doing in this loop is running some quick checks. We're saying, has the person hit a button or give me some sort of input? If they have, change a number in the back, like behind the scenes, like is jumping is now true because they hit the jump button. And then it's going to run through the whole game loop and it's going to change whatever's on the screen in one tick or one frame, right? So if the screen's going to change the tiniest bit, then it's going to go back to the beginning of the loop and look for input again, change, loop, change, loop, change. That's all a game program is at its core. It's just a simple loop that's listening for input and changing the screen based on that. Everything else is procedural code based on whatever we're designing as game designers. We may have things that say, if the player is holding the B button and the ticks that have gone by since they started holding it is over 500, so it's been like 500 frames, change shield to fully charged or something along those lines. And so your loop will get more and more complicated as you add more and more code to your game. Just understand that the core of it at its basics is just this real simple check. Change the screen, listen for input. Change screen, listen for input. That said, when you start building more and more and more and more code to make this happen, it can get kind of unwieldy. The good news is we're talking large-scale game development. In large-scale game development, you have a lot of these different renderers and blocks of code and packages. We really don't need to reinvent the wheel. A lot of this stuff has been done so many times at this point that rather than try to recreate all of these things, we have tools to allow us to do a lot of the things that we intend to do. And this is where game engines come in. Game engines are programs that are designed to prevent us from having to reinvent the wheel. These are companies or individuals who have developed solutions for various tasks. So if we need to render sprites, which is to say we have to display sprites on screen so they show up. Do we need to write a 2D library that's going to run a two-dimensional, for loop and go like, on this part of the screen, draw a red dot, on this one, go green dot, red dot, green dot, It's overkill. We know how those solutions are optimized, so engines do a lot of that simple stuff for us now. There are a number of different engines to choose from. So the ones we got displayed here are Unity, Unreal, Construct, Source Engine, CryEngine. A lot of companies now make their engines freely available to the public. As you can imagine, this is a great benefit to these companies because if you sit there and you master their software that they use in their own development house and you all use it, when they go to hire more employees, they can go, oh, do you have experience in our engine? If you're looking to get a job at Bethesda, do you have experience making mods for Skyrim? If you're going to get a job, at Blizzard, do you know like how many World of Warcraft mods have you made in LUA? If you have experience working with the tools that they want you to work with and they've made those tools available to you, that's less training those companies have to worry about, and you can hit the ground running with them. So. For the purpose of this demo, as I mentioned, we're going to be using Construct. Construct is a simpler engine. It's designed primarily for developing 2D games for the web, although it has a number of different export modules. So here's kind of a stack. And I want you to think of this as levels of complexity. At the very bottom is literally the electrical current running through the circuits of whatever piece of hardware you're running something on. And it's the hardware itself, the BIOS, or the software that's making the hardware run. The operating system, Windows, Linux, whatever is running on that BIOS. The application is the game, the program you're running, right? The game engine helps you develop that application, and then sitting on top of that is your game. It's a very, very simplified sort of stack. For the purposes of this talk, we're going to be sitting way up at the top of this. We're going to be developing Awesome Game, a little newer than 2013, and we're going to be focusing entirely on the game engine. So with that, let's go ahead and hit the ground running. We are going to pop open 3 programs, Construct, Piskel, and Beatbox, and we are going to develop the simplest game possible with whatever time we have left in this panel. So, show of hands, who wants to start with the engine first? All right, good number of people. Who wants to start with the music first? A few people. And who wants to start with the sprite work first? All right, I think the engine won out, but barely, so we're going to jump into Construct. So Construct, editor.construct.net. This is an online engine. So you do not need to download Construct. If you have an active internet connection, you can go to construct.net and you can just start working in your browser. Some of the advantages of Construct you'll find, it's drag and drop, it's very simple. You can test your games in browser as well, and it has some very simple export modules. There is a free edition. If you sign up with your email address, you get a couple additional features unlocked, but to use the full version of Construct, I think runs something along the lines of $100 a year. So let's go ahead and create a new project. We're going to give our project a name. Why don't we do TMG 2018? For our preset, since we are going to be developing a very simple game, we'll go retro style. We'll do 320 by 240. That's a nice resolution, nice and small. We'll optimize it for pixel art, and we'll keep it with the standard orientation. Great. All right. What we are looking at now is the basic editing window in Construct. Up here at the top of the screen in the middle, we have layout and event sheet. The layout is, think of it like the table. This is where we're literally setting our things down to use. And then the event sheet is where we'll do all our programming. This is kind of it's a scripting thing. All we'll do is put in a series of events and things to happen when that event triggers. The properties window on the left side of the screen gives us some basic options to change something we've selected. So like when we have our layout selected, our layout might have a name. We'll call it, level 1. We'll change the size to 320 by 240 since that's our screen size. You'll notice that we just shrank our piece of paper, right? Because our screen is only 320 by 240, our game is only 320 by 240, so we don't need all that extra real estate. If we wanted to make a larger game, like say 320, actually let's do triple that. So we'll do 960 by 240. You'll notice it extends out that way. So maybe if we're making a side-scrolling platformer, we're going to stretch our screen way out to the right so we've got some room to run. If we need to move in that window, we can do that. So we've got a nice little strip here we can work with. We've got a grid we can put in, so it's 32 by 32 pixels if we need the grid. I don't think we do. We're good there. So let's go ahead and add something. Why don't we go ahead and insert a new object. We'll start with a background. So let's create, we're going to make a sprite for our background. We'll call this background. And just click anywhere. It drops you into this very simple drawing tool that we can use to create a background. As it is, we're just going to make a nice little, it's nice, bright, and sunny out today. So let's get a nice light blue sky, get our paint bucket tool, fill it in there, and close. Done. Now we're just going to take this, and since we have a solid color, we're not worried about anything weird with the ratio and skewing for the pixel art, so boom. Now we've got a background for our sky. Let's go ahead and create another sprite, and we can create, then we'll call this one ground. And again, just a real simple fill with a color. We'll do a nice shade of green here, our fill tool, and done. This doesn't need to be very big because it's our ground, so we can just drop this on the bottom of our screen, hang it out over there, and again, stretch it all the way over. All right. Now, if we hit this little plus button, we are running a game. That is our game running on screen in Engine. How beautiful is that? Now, it is missing some stuff, right? We don't have a ton going for our game yet. So let's start filling some stuff in. Let's start with some text. So we'll insert a new object. We'll create some text. And we'll call it, I don't know, score. All right. So we'll put a score field here. Now, that's ugly. I don't think anyone wants whatever this is. Arial, I guess? Yeah, that's Arial. So let's import a better font than Arial. So we can go over to our project folder on the right. And our project folder on the right stores all the assets that we're going to be using. So if we're bringing anything to the game, you'll notice we have background, ground, and score. So things we've created in the engine are already over here. But we can say right-click fonts and import a font. And I have sitting and waiting for me here, joysticks. Now, joysticks was made by Ray Larrabee. It is a public domain font, so it's free for us to use for anything we want, commercial purposes or whatever. So for our demo, this will be great. So now we select our text object. Remember, notice how the properties window on the left changes. It's context dependent. So if we have our background selected, it's going to give us things about our background. If we have our font selected, things about, whatever. In this case, we want to select our score text box. Go down to font. Change it from Arial to, oh, that's much more gamely. There we go. There we go. See, now we've got text, right? Much better. And what should this text say? Well, TooManyGames 2018? All right, so let's make that large enough to display. We'll just hang that up in the middle of the screen. Hey! Now we've got an awesome intro screen for our game. Beautiful. But this game is going to need a character soon, or something, or someone to interact with. So why don't we go ahead and jump into our next tool, which is going to be our sprite editing tool, which is Piskel. Now, Piskel is available through the web at piskelapp.com, but you can also download a standalone version. So I've downloaded a standalone version of Piskel here. Now, we're going to resize our sprite, okay, 32 by 32, very simple sprite. We're going to anchor it to the middle, set default, boom, done, cool. All right, So now we just have a very simple drawing tool here. So we're going to make a character. Why don't we go ahead and make what we would describe as a programming art character here. All right, so a nice, simple, playing piece style character. Grab a fill tool. We have palettes, right? So we need to. I don't have the import. I don't have my NES palette downloaded, do I? Okay. I have a pre-configured palette in Piskel at home, which is all the available colors for the NES, but we can just cheat and use whatever colors we feel like. So let's give our character. We'll go purple. That stands out. Whoops. And for the magenta. All right. So add a color. We'll go more. That'll work. A little brighter. It's already full. Yeah. Okay. That's oops. There we go. All right. So there's a character. Now the nice thing about Piskel is if you want to, you can duplicate frames. So now all I have to do is create some pen, and let's add a color. Let's throw black in there. So red 0, green 0, blue 0. Done. All right, select black, and then here's some whooshy, streaky lines. So when our character is moving to the side, they will leave that trail behind them, right? Beautiful. And then we're going to duplicate this frame again. Move that here and do the same the other direction. Whoops, that's a little too far. I want to stay in frame. Whoosh, whoosh, whoosh. Okay. So now our character can go left and right, and we'll have some incredibly dynamic effects as they move. Now the good news is we can also, let's say, export this. And we can automatically convert it to a sprite sheet of PNG format, so 32 by 32, normal scale. Just download it. We'll save it in our assets folder and save. And it will build that automatically. And then in our assets folder, here's our new sprite sheet. As you can see, as you can't see because Windows 10 decided to do dark backgrounds for stuff. But see, we've got our little pixel sprite here. And it's done in sprite sheet format, which is great because when we go back to construct, we're going to create a new sprite, insert new object, sprite. All right, our hero needs a name. Names.
Little Buddy.
Little Buddy.
Purple guy.
Little Buddy it is.
I was going to say purple.
That's Five Nights at Freddy's.
Oh, you'll notice it removed the space in the name Little Buddy because it needs to be one contiguous thing, so Little Buddy it is.
It's a family name.
All right. So now we have our sprite editor like we did before, but we're going to go down to the animation frames, right-click, and we're going to import our frames from a pre-existing sprite strip. We're going to select our new Piskel, open. We know it's a 2x2 because that's what we made it in Piskel, and we're going to replace the entire animation, which will get rid of this blank at the bottom. There we go. Now we have our character. If we zoom in, and you can see their frame-by-frame animation. Now, to simplify this, we can simply duplicate our animation 3 times. We're going to rename this one to Still. We'll rename this one to Move Left. We'll rename this one to Move Right. All right. Now, for the Still animation, we will delete the frames that are not standing still. For moving left, we'll delete the frames that are not moving to the left. And for move right, we'll delete the frames that are not moving to the right. And just like that, we've got a animated character that we'll be able to utilize in Engine. So we can close this out now. Actually, let's just make sure. So yeah, none of these need to have a loop or speed set because they're all one-frame animations. If we had multiple frame animations, they would be like in a film strip along the bottom. And I can show you that a little later with one of my pre-done characters. So we'll drag our little character here, and we'll run. So Little Buddy is now in the world of TooManyGames 2018, but Little Buddy doesn't know how to do anything. So we're going to have to give Little Buddy a behavior. behaviors are the first kind of building block for developing in this engine. So we're going to need to right-click Little Buddy, and we're going to edit some behaviors. We're going to add, in this case, we're going to add the behavior of platformer. So this allows him to behave like a standard platforming character. And we're going to add scroll to, because we want the camera to follow Little Buddy at all times. And that's it. That's all we have to do there. Then we're going to jump over to our event sheet. And our event sheet is where we would add any code that we need to add for our game. So in this case, right, Little Buddy, we're going to say is moving. Yeah, so we'll say is moving. We're going to add the action, Little Buddy, set animation, and we're going to switch him to move right. And done. And then we're going to create another event, Little Buddy is moving. And then we're going to right-click that and invert it, so now it's Little Buddy is not moving. We're going to set the animation to the still animation. All right, and then the last thing we're going to do is we're going to go back to our level, and we're going to select our ground, and we're going to give our ground a behavior because our ground needs a behavior. We're going to give it the behavior solid, so Little Buddy doesn't fall through the world when we start this up. Because we have added gravity to Little Buddy, and he's going to appreciate that. So it's going to run. Oh, no. Uh-oh, call quality assurance. It's not running. Well, while this is deciding whether or not it wants to run, we have some time. We're going to jump over to the last thing we still need to do in our fastest game ever made, and that is music. Beatbox, available at Beatbox, is a program for developing music in very simple loops as quickly as possible. So, with my amazing compositional skills, I'm going to add all right, let's get a second line in there.
Dang song.
There's like drums. Those are drums.
All right, now we're going to really kick it up. We're going to go from a rhythm of 4. Let's go triplets.
The drums might be a little
You're a master class
All right, good enough. We'll have the testers tell us if they like it or not.
drums might be a little off.
Yes.
The original was a good jam.
All right, we can switch it back to 4 time and see what that sounds. That might work better.
Yeah, that's better.
All right, clean it up a bit. All right, good enough. All right, so let's pause it and we're going to export that. This is our amazing song. We're going to export it to WAV file. We have our WAV file. Let's go into our assets. Let's grab our WAV song.
Too many notes, 2018.
Yes, too many notes.
So mad I didn't.
So now let's go ahead and right-click music and apologize to Construct as we import this amazing composition.
Sorry.
All right, so it is complete, import, right? And then we're going to go back to our event sheet and add event system. So let's say on the start of layout, so when we first run this layout, we're going to system, let's see, we need to add, let's see, Little Buddy score. Oh, we need to add to our thing. So insert new object. So we've got a light, keyboard, audio. So we need to insert an audio object, and now we can reference that audio object here. So we're going to play beatbox Yeah, we're going to loop it. And done. All right, so then we go back to this, and let's try again, see if this is going to run.
Maybe save it first.
Yeah, so you can project, let's go ahead and export this. Or if we're exporting it, you can create it for web, Android, desktop, iOS, Windows, Xbox One. Obviously, some of those you have to pay for the full version of this to do. In this case, we're just going to save and download a copy as TMG 2018. Then let's go ahead and reload editor.construct.net. We're going to open this file that we just downloaded. So downloads, TMG 2018, and let's try running again. Still doesn't like it. So we have done something to damage our build. We'll have to figure out what exactly. Was it Little Buddy that did it?
It was the
animation.
It was because of the music.
Little Buddy.
Little Buddy's responsible for this. So,
Little buddy, how dare you?
all right. Well, Little Buddy is going to get nuked.
Oh, it runs now.
And our game lives again.
Like that. Less harsh, not say
Why don't we
you
just
can't.
play as the TooManyGames test?
Okay, let's do that. Let's go into our event sheet. No, we'll go to our text. Let's right-click our text and see if we can add behaviors. And we can add the platform behavior to our text. And we're going to add the scroll to behavior to our text. And we're going to run this. No, doesn't like it. So it doesn't like, is it the platform behavior maybe? Let's see, behavior. Let's get rid of, oh, hold on. Let's look at our scores behaviors. Let's try removing scroll to first and see if that does it. Oh, there we go. Hey! We have a playable.
Maybe we have to get rid of Little Buddy.
All right.
So reload the file.
So.
And then take away the scroll to. We'll have Little Buddy.
Yeah, there you go. So let's go ahead and open.
Better, stronger. We can unnuke
We can use
him.
the Dragon Balls.
All right, so
We can use the Dragon Balls.
scroll to is what was doing it. So Little Buddy's behaviors, scroll to, delete. All right. Hey.
He has a problem. He doesn't have.
Yeah. Why does he not? So this is a real quick question. Why does Little Buddy not?
Oh, because you can set it either.
What? Oh, thank you. So grab something, and yes, because again, we would have to go. Hey, no, it's not even mine. So you would have to go into your event sheet and add the ability for move and right. But as you can see, like it's incredibly quick and easy to start knocking this stuff out. In less than a half hour, we went from having absolutely nothing to having maybe the best song written in the last 5 years. A playable game with a memorable main character who has an incredible story arc of dying and then coming back.
Getting nuked.
More dynamic text than you've probably seen in a long time. So this is kind of the main point of the panel here. A lot of students come into game development, and the great fear is that inertia of being able to do this. And what I want to impart from everybody as you walk out the door in the next few minutes is this is not as hard as it seems. Game development is very, very complicated. Most of the main games you think about that you're buying for $60 these days are made by teams of dozens to hundreds of people working diligently for many, many hours to develop that product. But you don't have a team of 1,000 people. You don't have 5 years. I would encourage you, if you want to get into game development, one of the best things you can do is just start making games. How many of you right now, show of hands, have an idea for a game? Not shocked at all. 90% of my students say the same thing. And you love the idea for your game, do you not? Yes. I'm going to give you 2 suggestions right now because you saw how good this game was, right? Suggestion number 1, destroy your idea. Try to make your idea. See it come to fruition. Realize that, oh man, I'm not great. You're going to feel terrible about your idea because you built your idea up in your head. You're going to make your idea. If it falls apart, so be it. On to the next game. Second option, which is a relatively new one, you can thank James Cameron for this idea. You can use option 2, the Cameron. Take your golden baby, wrap it tightly, put it up on the shelf. Do not make the game you're thinking of. Make millions of other games. Start practicing with Construct. Start making sprites. Start making music. Get together with your buddies. Start developing games. Build an online portfolio of stuff. Get stuff under your belt. And then 10 or 20 years later, when you are the best game developer of all time, then you're like, oh, my golden baby. Now I can make it perfect. Because if you try to make that game you have in your mind right now with the experience you have as a game developer, how you've built it up in your head and how it's going to appear on the screen when it's all said and done is never going to match up. And I don't want you to feel discouraged. I want you to feel like you're capable of doing this, or you're certainly capable of growing as you do this more and more. So yeah, option 1, nuke it. Option 2, set it aside and start making games starring Little Buddy. Because honestly, I want you to make games. And not just because I work for a university that teaches students how to make games. I've been playing these things for decades, and I will tell you some of the greatest experiences I've had playing games are games that were made by 1 or 2 people in their garages, in their free time, when they were trying to develop something fun and they just hit upon a really great idea. And they became independent developers or enthusiasts, or they went on to work for companies. I've had students that have made games in 24, 48-hour game jams that have been a total blast. And if you've never been to a game jam, go do a Ludum Dare, do a global game jam. It doesn't matter if you've never touched a game engine in your life, you can help. We've had game jams where people have made traditional games, game jams where people have just been creative idea people that have sat with others and watched and observed and seen the creative process. You don't get a lot of sleep during a game jam, but you learn a ton during it. With that, the last thing I want to do before they kick us out of the room is open this up to some Q&A, because I do have a few items left on the table, and I would love to give those away, and I would love to make sure that everybody walks out of this room knowing what they feel like they need to know to start doing this. Here in the corner.
What do you think of the game engine Scratch?
I think Scratch is great from an educational perspective. I don't think Scratch is terrific if you want to try to take it out and show it outside of the game development world, but I really like Scratch as an educational tool, like especially in schools for teaching game development. So thank you, and grab something from the table. Here.
Yes. What's your opinion on, let's see, purchasing assets?
If you have an idea and you really want to see it executed, and you can't find somebody to work with you or make that stuff, then feel free. I would avoid using a lot of purchased assets and commercial stuff because, A, people who buy it and recognize the stuff, it immediately makes you look more hobbyist enthusiast. So if you're trying to make a commercial product out of it, it's not necessarily the best thing. And there are a lot of artists that are looking to do work out there. There's tons of 2D and 3D people that'll be happy to commission stuff for you right now. So if you want to get something made for it, it's not as expensive, and the gap between having it made or having it available in the asset store isn't as big a gulf as it may seem. They're not necessarily a bad thing. Like anything else, it's kind of how you end up using it. And if you want to grab something, go for it. In front here.
A little bit more of a complex question. For making a 2D game, what would you use? Would you use Unity or Game Maker?
I would personally use Construct just from the experience I've had, and I use it to teach 210 students. The only beef I have with Construct is it doesn't export to as many things as like Game Maker does. And Construct does have a WebGL background, which will complicate it if you're trying to export. Like, I don't think it's ever going to be compatible with Switch, or if it does, I'd be shocked, because Switch is HTML5 support's kind of wonky. If you're making games for PC, that's a great 2D thing to start. You can never go wrong learning Unity. Unity is getting bigger and bigger and bigger. It's taking up a larger and larger chunk of market share, and there are a million tutorials out there. We had one over here behind you, sir.
Oh.
Yeah.
Do you have any recommendations for an engine for hand-painted things?
For hand painting stuff, I would start with, if you can't get your hand on Photoshop, GIMP is a free alternative to that has about 80% of the functionality that Photoshop does without the $50 a month subscription fee.
Is there like a particular engine that's friendlier?
Unity's actually very friendly with hand-drawn stuff now, because the collision boxes that are created can mutate around the edges very nicely in the very, very far back.
Yeah, are there any like good say open source platforms that you contribute, and are Would there be any that are better than Texas?
A number of the platforms that exist are open source, but going into the repositories and getting them are kind of wonky. For the most part, you tend not to interact with the code on the back end because then it makes it very difficult to kind of support your problem. The whole point of an engine is that you're working from a predictable code base and that everything else is then built on top of that. So typically the engine code isn't something that's scattered and bandied about. Sir, here.
What websites would you recommend to like put your game out there for like, oh, I'm testing out
For
the game.
people, yeah, for people seeing your game, social media is still your strongest bet. It's very easy to have a website and host your game on a website, and even like major programs like Unity and Construct are both going to be able to export to web and people play it directly in browser. There is stuff like Congregate, and although Flash will be deprecated very, very soon, Newgrounds was always a great exposure site for some people. There are places out there to get your game out there, but I will say at this point, being in the right social communities and kind of getting your game out to them is going to be more effective than trying to be at a site that's a sort of a game-centric site, because they're not as visited as they used to be.
Does your university offer game music courses or game music
We do.
Is there like a master's that you can focus in?
There's a master's in music that you could do. We have actually one of our professors at Mason in the music department did an amazing breakdown of, I believe she was analyzing Ice Cap Zone from Sonic 3 and how it corresponded to like New Wave and some of the inspirations from that and the band, like the New Wave band that was responsible for the tracking process. It's actually really, really... we do get a very wide variety of focuses at George Mason. So we have art and animation students, music students, designers, programmers from all walks, both in the bachelor's and master's of the program. I think I have time for two more, so, sir.
Could you talk a little bit about marrying creative and technical? One of the issues I've seen is a lot of games created by masterful technical coders who are absolutely rudimentary storytellers, and in the flip, masterful storytellers who have absolutely rudimentary technical skills.
I would say that almost more than any other art form, because games are so multimedia, they're almost always better when they're collaborated on by multiple people. Having a good artist, a good musician, someone who's got the technical chops to work on it, and being able to work functionally as a team. I never let my students get out of a class without doing at least one group assignment. I'm sorry, I know a lot of people get issued about group assignments. Game design is such a collaborative thing that it really, really helps. Now, you will have some people that are jacks of all trades that are capable of doing it all, but it's the exception and not the norm. So I would say it's the collaborative part of it that really makes the difference. And then back by the door for our last question.
So what would you recommend if you're trying to make a game but you're better at the art than the programming?
Make a friend. And barring that, if constructs, drag and drop, real simple, like if I moved right, change my animation to move right, is a great way to start if you're afraid of programming, because you can actually make a pretty competent game in a lot of these drag and drop game engines that don't require you to understand big O notation or understand polymorphism or object-oriented programming or any of these sort of things that can be very, very intimidating when you see them like on their face. Computer science is a very complicated thing. We've been working on it we're closing in on a century. So it can be intimidating to sort of stare down the face of a modern, programming language and feel like you need to master it in order to produce a game. If I give you anything to walk out of this panel with, is you don't need that level of mastery to start making games. You may need it to make the best game, and you may come back 5 or 10 later and revisit your old games and have a good chuckle that you made this silly game in a little web engine that is so unoptimized and runs at a bad frame rate and the controls are janky and floaty or whatever. You will always find better ways to do stuff. But you can't master something until you are advanced at it. You can't be advanced at it till you're intermediate at it, and you cannot be intermediate at it till you're willing to really try it for the first time. And that's kind of the main point of this panel. I want to get that inertia running. I want everybody in here at some point, like tonight, tomorrow, whenever you find yourself in front of a computer again, fire some of this stuff up, try it. You'd be amazed how easy it is to do and how much fun the creative process can really be if you're that interested in making games. And with that, I am out of time, so thank you all very much for coming out here.